is Artem, and for today's video we're gonna study a little bit. So for today's video we're gonna study a little bit of SQL, because in order to get applied for a study at a company I need to know SQL, and well, obviously I don't know it. So yeah, for today's video I wanna continue my study with some ASMR. Yeah, so yeah, SQL review, simple select queries. You've done a good job getting to this point. Now that you've gotten a taste of how to write basic query, you need to practice writing queries that solve actual problems. So yeah, exercise and the exercise below, you will be working with a different table. This table instead contains information about a few of the most populous cities of North America, including their population and geospatial location in the world. Positive latitudes correspond to the northern hemisphere, and positive longitudes correspond to the eastern hemisphere. Since North America is north of the equator and west of the prime meridian, all of the cities in the list have positive latitudes and negative longitudes. Try and write some queries, right? To find the information requested in the task below, you may have to use a different combination of clauses in your query for each task. Once you've done, continue on to the next lesson to learn about queries that span multiple tables. Okay, list all the Canadian cities and their populations. Okay, we need to select everything from North American cities where city is equal to Canada. No. Wait. Oh, where? Wait. Why is not? Wait. What's wrong here? Where? Okay. Well, select everything. Where? Country is equal to Canada. Okay, here we go. Order all the list, all the cities in the United States by their latitude from north to south, right? We need to United States, and we need to order by, we need, okay, north, it's latitude, right? Latitude, latitude and decimal. List all the cities west of Chicago, ordered from west to east. So we need to order by longitude, or from the west to east is less than this one, I guess. Yeah, right. And we need we don't need this one. And I'm not quite sure. West, is it west of Chicago? Well, order by longitude. Where? I guess where longitude is less than, maybe. Maybe not. Okay, and well, I guess order by longitude. Yeah, I'm sorry. List the two largest cities in Mexico by population. Okay, I need where country is equal to Mexico, and order by population, and we need to set limit to, and we need decimal, right? largest cities by population in the United States and their population. Okay, we need to change it to United States. Then we need offset is equal to offset to. Yeah, here we go. Everything's done. Okay, SQL lesson 6, multi-table queries with joins. Up to now we've been working with a single table, but entity data in the real world is often broken down into pieces and stored across multiple orthogonal. And now how to write this one. Tables using a process known as normalization. Database normalization is useful because it minimizes duplicate data in any single table and allows for data in the database to grow independently for each other. For example, types of car engines can grow independent of each type of car. As a trade-off, queries get slightly more complex since they have to be able to find data from different parts of the database, and performance issues can arise when working with many large tables. In order to answer questions about an entity that has data spanning multiple tables in a normalized database, we need to learn how to write a query that can combine all the data and pull out exactly the information we need. Tables that share information about a single entity need to have a primary key that identifies that entity uniquely across the database. One common primary key type is an auto-incrementing integer because they are space efficient, but it can also be a string hashed value so long as it's unique. Using the join clause in a query, we can combine raw data across two separate tables using this unique key. The first of the joins that we will introduce is the inner join. Inner join another table on my table ID, from my table is equal to another table ID. The inner join is a process that matches rows from the first table and the second table which have the same key as defined by their own constraint to create a resultant row with the combined columns from both tables. After the tables are joined, the other clauses we learned previously are then applied. Okay, so first of all we need to group two tables. Let's see queries where the inner join is written simply as a join. These two are equivalent, but we will continue to refer to these joins as inner joins because they make the query easier to read once you start using other types of joins, which will be introduced in the following lesson. Okay, we've added a new table to the Pixar database so that you can try practicing some joins. The box office table stores information about the ratings and sales of each particular Pixar movie, and the movie ID column in that table corresponds with the ID column in the movies table 1-to-1. Try and solve the task below using the inner join to introduce above. Find the domestic and international sales for each movie. Okay, we need to inner join box office, and we need where movies ID. No, wait. Am I right? Oh yeah, I'm stupid. I'm a little bit stupid. Okay, we need on movies ID is equal to box office movie ID. Nice. Yeah, well, we're done. Show the sales numbers for each movie that did better internationally rather than domestically. Okay. Okay, here we go. The sales number. And where? Okay, we need to where box office international sales is greater than box office domestic sales. Right, let's go. List all the movies by their ratings in descending orders. Okay, where? Order by rating, right? decimal. Yes, let's go. Depending on how you want to analyze the data, the inner join we used last lesson might not be sufficient because the resulting table only contains data that belongs in both of the tables. If the two tables have asymmetric data, which can easily happen when data is entered in different stages, then we would have to use a left join, right join, or full join instead to ensure that the data you need is not left out of the results. You need we have inner left. It's mean like left table is being kept right. Okay, here it will be described, I guess. Like the inner join, these three new joins have to specify which column to join the data on. When joining table A to table B, a left join simply includes rows from A regardless of whether a matching row is found in B. Yeah, that's what I was talking about, yeah. The right join is the same but reversed, keeping rows in B regardless of whether a match is found in A. Finally, full join simply means that rows from both tables are kept regardless of whether a matching row exists in the other table. When using any of these new joins, you will likely to have to write additional logic to deal with nulls in the results and constraints. You might see queries with these joins written as left outer join, right outer join, or full outer join, but the outer keyword is really kept for SQL 92 compatibility, and these queries are simply equivalent to left join, right join, and full join respectively. In this exercise, you are going to be working with a new table which stores fictional data about employees in the film studio and their assigned office buildings. Some of the buildings are new, so they don't have any employees in them yet, but we need to find some information about them regardless. Since our browser SQL database is somewhat limited, only the left join is supported in the exercise below. Okay, so now find the list of all buildings that have employees. Okay, we need from employees. Yeah, and we need. Okay, first of all, we need. We selected everything from the employees table. Yeah, then find the list. Left join. Okay, buildings. On employees building is equal to buildings building name, I guess. Building name. Find the list of all buildings that have employees. Or wait. The list of all buildings that have employees. Well, I think I did it. No, didn't I? Find the list of all. Maybe we need. Wait. Of all buildings that have. Maybe we need from building and here employees, and I guess we need to do this one and this one. No such table building from buildings, and the list of all buildings that have 1E. Oh wait, no, I mean we need only, yeah, I did it right on the first time. So yeah, employees, left join buildings on employees building is equal to buildings building name, and maybe I need distinct. Maybe no. Okay, I guess not. What's wrong? Find the list of all buildings that have employees. Select everything from employees. Left join buildings. Yeah, we connected it. It's here. Buildings. Maybe such tables. No. Employees building is equal. Find the list of all buildings that have employees. Well, read this task solution. Now wait. I need to think about it a little bit. So we found, yeah, we don't have one W or two E. Yes, we can see. Find the list of all buildings that have employees. I don't know, maybe distinct somewhere. Maybe distinct. I think that I should use it somewhere, but I don't know where exactly. Maybe building only. Oh yeah, God. Gosh. I thought as far as it, like, asterisk is built in by default, I thought that I need to, yeah, import the whole table, but no. Find the list of all buildings and their capacity. Okay, so we need everything from buildings, right? Buildings. And we need just, I guess we need, yes, that's all. List all buildings and the distinct employee roles in each building. So we need building name, from buildings, and okay, let's go like this one, and we need employees. Why can I? Oh, please, thank you. Role, yeah, employees role. Distinct. How can I do it? Employees role. Yeah, I know that it, like, wait, list all buildings and the distinct employee roles in each building. Okay, so, okay, let's try this one. Okay, select building name from buildings, then we go left join employees, and can I add only role? No, I guess I can't for some reason. I don't know why. On buildings, building name is equal to employees building. For some reason it doesn't want to. Why doesn't it want to left join employees? Why don't I have this one? Employees buildings name. Why doesn't it want to? I guess, okay, let's try this one. Employees role, because I saw that I can possibly do it, but I don't remember how can I do it. Why does employees don't want to be here? I don't know. Building name is equal to employees building. Everything is right. Why doesn't it want to? Oh yeah, I see why. Oh gosh, I'm stupid. Can I go distinct? No, I can't. Wait. Probably it was the reason why can I do it. Employees role. Yeah. Distinct. have to put it right here. No. Okay, for some reason no. Why no? Why no? Why distinct. Row left join employees dot row maybe. No, I need a table, yeah. Left join employees on building's name is equal to employees building. Okay, I don't know. Distinct. Yeah, right. Distinct. What's wrong here? From buildings, left join on buildings. Building name is equal to employees. Well, okay, I can see it. I can see it. Wait, I can distinct asterisk employees role from buildings. Left join employees on buildings. Building name distinct. Why doesn't it work? I mean, it must be working, but it doesn't for some reason. Distinct. Am I right? I think it distinct. Yes, it's right. Employees role from buildings. Maybe I should type like this one. I know, like, I don't know, really. Oh, really? Oh gosh. Are you serious? That's kinda, yeah, wait, what did I do? I mean, oh, god damn. I'm such a stupid. Okay, SQL has an 8 short note on nulls. As promised in the last lesson, we're going to quickly talk about null values in an SQL database. It's always good to reduce the possibility of null values in databases because they require special attention when constructing queries. Constraints certain functions behave differently with null values and when processing the results. An alternative to null values in your database is to have data type appropriate default values like 0 for numerical data, empty string for the text data, etc. But if your database needs to store incomplete data, then null values can be appropriate if the default values will skew later analysis. For example, when taking averages of numerical data, sometimes it's also not possible to evaluate null values, as we saw in the last lesson when they're joining two tables with asymmetric data. In these cases, you can test a column for null values in the where clause by using either the is null or is not null constraint. Yeah. This exercise will be a sort of review of the last few lessons. We're using the same employees in buildings table from the last lesson, but we've hired a few more people who haven't yet been assigned a building. Find the name and role of all employees who have not been assigned to a building. Okay, where? I mean, yeah, I guess where building is null. I guess, yeah, that's right. Find the names of the buildings that are old, no employees. Okay, I guess we need to find the names of building that are old, no. I guess we need from buildings, and we need, I guess building name. Yeah, I guess building name. Then we go on left join. buildings, employees on buildings, building name is equal to employees building. Something doesn't work either. I guess I don't know why. Okay. And building name is equal to null is null, right? No, wait. And building's name. Wait, what? I guess we need something like this one. I'm not no, maybe. And building, maybe employees building. Employees building is null. No, for some reason it's not working. Is null or is not null. Okay, well. Okay. I've done something that's cool. And maybe wait. It's not null. Wait on building and where? No, wait. On building. Wait. I think I'm an idiot. I guess I'm an idiot. I guess. Where is null? Okay, maybe I'm not. I'm not. Where is null? Or maybe employees building. Oh gosh. Yeah, it's too hard for my brain. I swear to God, I'm an idiot. I'm a pure idiot. SQL has 9 queries with expressions. In addition to querying and referencing row-column data with SQL, you can also use expressions to write more complex logic on column values in a query. These expressions can use mathematical and string functions along with basic arithmetic to transform values when the query is executed, as shown in this physics example. Select portable speed as okay. It's like aliases, right? Each database has its own supported set of mathematical string and data functions that can be used in a query, which you can find in their own respective docs. The use of expressions can save time and extra post-processing of the result data, but can also make the query harder to read, so we recommend that when expressions are used in this select part of the query, that they also given a descriptive alias using the as keyword. In addition to expressions, regular columns and even tables can also have aliases to make them easier to reference in the output and as a part of simplifying more complex queries. Okay. You're going to have to use expressions to transform the box office data into something easier to understand for the tasks below. Okay, we need to select box office. I guess domestic sales plus box office international sales. Yes. As and divided by 1 million. 1,000, 10,000, 100,000, and 1 million as millions. Millions from movies, no such column. Domestic sales, box office. Why not? Domestic domestic sales, domestic sales. No such column. Okay, wait. Okay, left join box office. Their combined sales in billions of dollars. Okay, we have it here. We have it here. Okay. List all movies and their combined sale. Okay. Where movies ID is equal to box office movie ID, I guess. Yes, okay. Okay, I guess so. List all movies and their ratings in percents. I guess we need to get this box office. Okay, wait. Box office rating and just simply multiply it by 10 as percent. Oh, okay, it's done. Okay, good. I got it. Okay, good. But wait, percentage. It's not. Oh, okay. List all movies that were released on even number years. Okay, I guess we don't need this anymore. And where movies is equal to wait, where is on, and then where movies here percent 2 is equal to 0, right? Is equal to 0. And let's complete the last lesson number 10, because I want to end on the even number. Yeah, SQL lesson 10, queries with aggregates, part 1. In addition to the simple expressions that we introduced last lesson, SQL also supports the use of aggregate expressions or functions that allow you to summarize information about a group of rows or data. With a Pixar database that you've been using, aggregate function can be used to answer questions like how many movies has Pixar produced, or what is the highest grossing Pixar film each year, without a specified grouping. Each aggregate function is going to run on the whole set of result rows and return a single value. And like normal expressions, given your aggregate function in alias, ensure that the results will be easier to read and process. Common aggregate functions. Here are some common aggregate functions that we are going to use in our examples. Count column. Okay, a common function used to count the number of rows in the group if no column name is specified. Otherwise, count the number of rows in the group with null values in the specified column. Min finds the smallest numerical value in the specified column for all rows in the group. Maximum, okay, the largest numerical value, average numerical value, and sum of all numerical values. Grouped aggregate function. In addition to aggregating across all the rows, you can instead apply the aggregate function to individual groups of data within that group. For example, box office sales for comedies versus action movies. This would then create as many results as there are unique groups defined as by the group by clause. Function column or expression as aggregate description from my table where constrained group by column. The group by clause works by grouping rows that have the same value and the column specified. For this exercise, we're going to work with our employees table. Notice how the rows in this table have shared data, which will give us an opportunity to use aggregate functions to summarize some high-level metrics about the teams. Go ahead and give it a shot. Find the longest time that an employee has been at the studio. And I think we need max of years employed. Maybe not. Okay. We probably select. Oh, okay. I guess I got it. We need to do this one and. Okay. But if I want to. Okay, I wanted to, to output the role name and his year employed. How can I do it? And I guess this one, yeah, this one. So, okay, then for each role, find the average number of years employed by employees in that role. Okay, we need to select role and average of years employed, and we need for each distinct. Okay, wait. I think I got something wrong. Engineer, then distinct. And then we're going to go average on years. How is it called? I don't remember. I'm sorry. Okay, I'm going to do this and going to do this. Years employed. Years employed. For some reason it's only manager. For each role. Role and okay, years employed. Okay, here we go, and the average number of years employed by employees in that role. Okay, we selected role, and then I thought that it would be logical, just do this one, but sound it's not. It's not. How can I do it? Maybe I can do something like this and years employed. I don't know. No. For each role. Okay. I guess I can group them up, maybe. Group by years employed. What will do it? I'm not sure what did that done. Why someone is missing? I mean, for some reason. 1, 2, 3, 4, 6. Okay, I got it. No, I mean, okay, select everything from employees. Okay, we got it. And then, okay, wait. Maybe just simply years employed. No, it's years employed. Manager. Let's see. Let's see. Is it true? Managers. Not no. No. Okay, I don't know. I don't know. Select role. Average years employed as average. Wait, why? Oh, I was right above it. I was right about it. Yeah, we are selecting roles. We're collecting average years employed. And then we're grouping by role. Yes. Yeah, I got it. Yeah, I got it. Yeah, I'm sorry, I'm stupid. Find the total number of employee years worked. Total number of employee. I guess this one some total number of employee. Okay, wait. I'm gonna do. Okay, this one we're gonna see how can we we're gonna the total number of employee years. We need to count, right? Count, select everything. We're gonna group by total number of years worked. Group by years employed, and we're gonna select everything and count name, I guess, name. Ow. As count. Wait, no. Select everything. Group by. Okay, we're gonna do this and then we're gonna count name. Why? I just don't understand. Why is it? Oh gosh, I don't understand anything. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, 13. That's good. But why is it only this one? The total number. Okay, I guess we're gonna do this one. No. Of employee years worked. Total number of employee years. Oh, wait. Employee years. I mean years employed. This one. Total number of employee years. Wait, I mean, maybe I'm not understanding it correctly. I don't know. Wait. No. Wait. No. In each building, I'm stupid. I'm stupid. Am I stupid? Am I stupid? Oh gosh. Group by. Building. God, I don't understand anything. I mean, really. I don't understand anything. I don't understand anything. We're gonna group by building. Or maybe not. Or maybe not. Or maybe not. We're gonna select everything and we're gonna select everything and okay, we need count function, right? We need count. By what? Why is it live in only, I mean, like 7 6. Why is it? Oh, select. Okay. I don't know. Building. Why not? Why not? I mean, why not? Find the total number of employee years worked in each. Maybe. I don't know. Some and years employed. I don't know. Oh god damn! I understood it wrong. Oh my gosh! I thought that I need to output like, how many employees in each building and not their years of employment. Oh gosh, I'm such a stupid thing. Okay guys, I think that here we can end today's video. Thank you for watching. I hope that this video helped you to relax. I don't know how it could be relaxing watching me stupid think doing some tasks, but anyway, with much thanks for watching this video. I hope that this video helped you to relax a little bit, and I wish you a good morning, a good day, a good evening, and of course a good night. See you later guys, and goodbye, goodbye, goodbye.